Okay, today we're going to take a look at 3/4 times 1/2. Now we're actually going to solve this in two different ways. Before we go through the algorithm of how to solve 3/4 times 1/2, I want us to take a look at exactly what does that look like if we had a diagram to try to illustrate exactly what 3/4 times 1/2 looks like. Well, the first thing I'm going to do is I'm going to draw a whole rectangle. Now, I want to draw 3/4. Well, when I look at my fraction, the denominator always tells us exactly how many parts our whole is going to be divided into. And in this case, it's going to be 4 parts. So first I'm going to be splitting it in half, and then I'm going to split each half in half to create 4 parts. Now, the numerator of our fraction tells us exactly how many of those parts we're dealing with. And in this case, we're only going to deal with 3. So I'm going to shade in 3 of the 1/4 that make up this whole. So this is a visual representation of the fraction 3/4. Now, before we get into multiplying by a fraction, what if I wanted to say, what is 3/4 times the whole number 1? That's like saying, I want to see 3/4 one time, or once. And in this case, that's exactly what it would be. 3/4 times 1 is, in fact, 3/4. Now, if we went as far as to say, well, what does 3/4 times 2 look like, another whole number? Well, it would be like saying we have 3/4 2 times, or twice. And so I'd actually have to draw yet another rectangle. Again, I'm going to go ahead and split it into 4 parts. Here's going to be the 3/4. And now, as you can see, we have 3/4 2 times. So if I count exactly how many fourths I have, we're going to have a total of 6/4. So 3/4 times 2 is going to be 6/4. So now that we're seeing what the representation would be if we're dealing with whole numbers being multiplied by a fraction, what exactly does it mean if I now want to multiply by 1/2? Well, that's exactly like saying that I want 3/4 half of the time. So what I'm going to do now is if I want to see 3/4 half of the time, I'm going to go ahead and take my diagram and slice it in half. By slicing it in half, now I have this portion, and this portion representing half of 3/4. But now when I want to figure out exactly what that fraction is going to be, you're going to notice that our whole is no longer divided up into 4 parts, it's actually divided up now into 8 parts. So now my denominator is going to be an 8. Now, in terms of my numerator, how many parts am I dealing with? As you can see here shaded in, I'm still only dealing with 3 shapes out of 8 now. So 3/4 times 1/2 visually is going to give us the fraction 3/8. Now, in terms of the algorithm, when we're multiplying fractions, let me rewrite this here. When we're multiplying fractions, according to our algorithm, we can actually just multiply straight across. If this was addition or subtraction, we'd be finding a common denominator, but in this case, with multiplication, we do not have to do that. So if we multiply straight across, let's see if we're going to end up with our same visual representation that we did here with this diagram. So what I'm going to do now is I'm going to combine both my numerators and both my denominators by writing it this way. 3 times 1 all over 4 times 2. Now, order of operation states that when we have something like a division bar like this, that we're going to go ahead and take care of the numerator and denominator separately first before we would actually divide or treat it like a division problem. So in this case, we're going to do 3 times 1 is 3, all over 4 times 2, which is 8. As you can see here, using the standard algorithm of just multiplying straight across, we ended up with exactly what we found when we had our visual representation with this diagram as 3/8. So 3/8 is going to be equal to 3/8. Since this fraction is in simplest form, it does not have, the numerator and denominator do not share a factor besides 1, this is going to be our final answer. And that concludes this demonstration.